Hello, my students. Now I would like to guide us through how to provide a complete description for a galvanic or a voltaic cell. For the complete description, you need to provide the entire balanced cell reaction, showing the oxidation and the reduction and making sure the number of electrons consumed is also given off. We also need to show the cell potential, or the EMF for the entire cell. We also would show the physical setup of the cell, so the drawing with the anode and the cathode showing the direction of electron flow. We also would show all the required species for the oxidation, the reduction, also the salt bridge, also the line notation. And so to jump right in, as we see, we are provided two reductions. I very much apologize. I'm not sure where the products disappeared to in the second reduction reaction, but it should be the permanganate ion plus 5 electrons plus 8 hydrogen ions yields 1 manganese plus 2 plus 4 water molecules. We want to take a look at these voltages and take their direction as to which reduction will become oxidation. And remember, we want to flip the 1 so that our overall EMF for the cell is positive. And so that will lead us to flip this top one. Because if we flip this, they both be much more negative when we added them together. And so this will be iron yielding the iron plus 2 plus 2 electrons. And when we flip the reaction, the sign of our voltage will change to 0.44 volts, positive. We keep the permanganate taking on the 5 electrons, 8 hydrogen ion, and yielding Mn plus 2 plus 4 waters. Okay, but we can of course note that the number of electrons given off and taken is not the same. Now I do want to give just a quick check to make sure everything else is balanced. 1 iron, fantastic. 0 charge plus 2, so I need 2 electrons to give me a 0 charge. 1 manganese, 4 oxygen, so I needed 4 waters. 8 hydrogen, so 8 hydrogen ion. We then have a total charge of positive 2. If we have a negative 1 and the positive 8, that gives us positive 7, so we need 5 electrons to be positive 2 on this side. The only thing that we need to do is to multiply through to make sure the total number of electrons is equivalent on product and reactant side. So multiplying this through by 5 and this through by 2. Then when we add everything, we would get 5 iron plus 2 permanganate ion will give us 5 electrons, which we hope will cancel, plus 16 hydrogen ion, yield 5 iron plus 2, plus 10 electrons, which cancel, plus 2 manganese plus 2, plus 8 waters. We want to make sure everything is balanced. To manganese. We have 5 iron. We have 8 oxygen, 16 hydrogen. We have a total of plus 10, plus 4, so plus 14. We have negative 2, plus that's positive 14. We're good to go. Now we would just add our E values to give us the E naught of the cell, which will be 1.95 volts, positive. So we would anticipate that this would be a spontaneous reaction for us. So here is our balanced reaction and the EMF of the cell. Now to the physical setup. So we want our anode, our anode on the left, and that would be our oxidation, which would be our iron. Now, the iron is solid state, so that is going to be my electrode. And then I need the complete oxidation, which of course would require the iron ion to be present, but I don't have anything else here. So, for my cathode, which remember, anode oxidation, cathode reduction. So, for my reduction, I just have ions. along with my water molecule, of course. So I need a solid state electrode. I'm going to choose platinum. Then I'll need a source, permanganate ion. I need hydrogen ion and the manganese +2. I will need a salt bridge to maintain electrical neutrality. The electrodes will be in contact through a wire, and that probably will be placed through something to get work out of it, and electrons will flow from the anode to the cathode. Make sure everything is here that I need. Yep. The only other thing is the line notation, and so I would want to start with my anode. I want to start with my electrode or solid state. I want to indicate that. Remember, we separate each phase with a single vertical line, separated from the iron +2 ion. We then have our salt bridge. We then have our permanganate. Commas separate things in the same phase. Let me show they're aqueous. And the manganese ion. And then our platinum electrode. Okay, so we have the line notation, we have the overall drawing of the cell, we have the balanced reaction, and then our EMF of our cell. There's another one on the second page here, but again, we are showing on the second page everything that I'm asking and that is ever asked of you in a complete description. So to just show my work, and you can of course pause to get a closer look at that. There is the balanced reaction, the EMF of the cell, still positive, so it'll still run. Just to show us, I mean, we can put the anode on the right, but it of course is just common practice to always put that on the left, but just to show us that variety. And there's our line notation, but in the line notation, the anode is always on the left, always, always, always. You can see some variation with the physical setup. Usually we favor the anode always to be on the left, but it absolutely has to be for the line notation. Thank you.